How are you guys doing? I guess we'll just wait for some more people. Yeah, we can wait a couple minutes until people join in. Can you guys hear me okay? Okay, cool. Oh, still people joining. Excellent. Let's wait for it, like 9:05, I think should be good. Well, 9:05, I think we can probably start. Okay. What's up, guys? We'll just be doing a basic tutorial and workshop on databases and SQL. So we get started. First of all, what are databases? Essentially, databases are just, all they do is they store data more efficiently and in greater quantities, such as their name suggests. And if you guys have ever learned any sort of, language in computer science, you guys probably learned how to write to a spreadsheet like a CSV file or a text file. And like, so the issues with those is, they have limitations, and the idea of it as your like professional recording like device, maybe not the greatest to save, valuable information on text file that can easily be misplaced. So those are the limitations of spreadsheets. So what we want to do is we want to work on databases. And essentially what a database is, let's go back one. And so where databases are stored, they're stored in the back end, right? And what we don't want to do, how do we want to connect to this information? It's a lot of effort if we want to write a full like front end application just to reach information that we have in the back. So what we do is, why write this whole thing to access something when we can just that can in a way like translate material that we can't access? Why not let's just speak the language of databases to access them? That's where SQL comes in. So SQL is a structured query language, and it's essentially just the language of databases. You don't exactly you don't code like solely in SQL. It's used in tandem with other languages, because what it is it's designed to send and retrieve specific information from databases. And what queries are essentially just searches. I guess it's short for inquiries of data. So what we do is in other languages, we send queries using the SQL language, and that's how we receive information. Okay, so also if you guys have any questions, by the way, feel free to either raise your hand or write it in chat or just speak up whenever. It doesn't really matter. So what we can do is we can go to select. And this is the most basic command you can learn in SQL. And essentially, like the name suggests, all you do is select data from a database. And so we have a super basic example of a command you might want to use. It's just select asterisk from cities. Everything you'll see on these slides, anything in blue, is essentially just like an SQL like keyword command. So you might be wondering, what's this asterisk? The asterisk is super basic. It is essentially just means from all. There's not much to it. So when we go back, what we see is select all the information from this table known as a city. And a table is like any sort of table you'd normally see on some sort of paper. Like, you'd have your X column, Y column, and what information is in what, and it just stores in a table. So in this basic command, select everything from cities, you just return all the information. So this is the most basic command you can do. However, this is sometimes, we don't necessarily want to select everything, or we not sure what's in the table to select, you don't want to hard code anything. So we start to bring in conditionals. And what we have is the where conditional. So what it is you use to specify conditions what you want when you're fetching data, and only values that satisfy conditions that you set are returned. And these are certain conditions we can use. We have the greater than sign, we have the less than sign, we have the like sign, and we have not, or sorry, not like sign, just like. We have not, we have between, and in. So a super basic example, again, let's build off of what we had before. So now we have select all everything from cities, where let's say there's a column known as countries, and where the country ID value, whatever it is in this set of values. So any country in this table, or any city in this table that has the country Germany, Egypt, for example, that's what we would return. Everything good so far? And likewise, if we use not, we do everything that's not in this list, right? So every country that isn't Germany or Egypt, return those cities. Less than, greater than can be used for examples such as you want to, from where, and let's say your condition is the value of, something easy. Just like, let's say you have some money value on everything between this set of money, like this price between this greater than less than equal to between. Options are whatever you want. And then you might be wondering, what's the like? So we have something called wildcards, and you'll see these in your queries, right? So the percent sign, means like 0 or more characters. So it's not necessarily you need anything there, but you don't know if there is. And then another wildcard is the underscore, which means like specifically 1 character. So examples, let's say you're looking through a list of, or a table of names, and return all the last names that are like and then you have A, and then the percent sign. So this can be a last name as short as A, a last name as short as 2 A's, 3 A's, via last name such as like A, and then 1, 2, 3, anything. Essentially, just as long as it starts with an A, anything after. In this example, would be if we had, let's say, an underscore O %R. That just means any last name that starts with any letter, doesn't matter, as long as it's one character and has an O in the second position, as many characters in between, and let's say an R character for the final character. And this is just another example. B underscore % underscore. It's just anything that starts with B and has at least 2 characters, 2 or more. So you can play around with this. That's how you just make any possibility depending on what you want to ask. And then we have order. Order is self-explanatory. You just sort the resulting information in ascending order or descending order. So example, back to our example, we're selecting all the cities from cities. And let's say we have a list of cities that we have, and we want to order this just by ascending order, ascending by city. So order is self-explanatory. And now something important is creating and deleting tables. So we have 2 commands there. It's just a create and drop command. So for example, if you want to create a database, you just write create database. If you want to drop it, it would be drop database, which is just to delete it. And then to create a new table, you would just write create table and the name of the table. And then if you didn't want the table, if you want to just delete the table, you have no use for it anymore, you can drop the table. So as you can see, most of these commands are pretty, self-explanatory, and they're not too incredibly difficult for the most part. Yeah. And then we go to primary keys. So primary keys are essentially, they are unique identifiers for each table. For example, something unique you could have would be, let's say you have a table that stores every student at UCSD. And everyone has a unique the student ID, because you got to be unique to have it. So you could set the ID to be your primary key. And what that does is essentially, if you try to insert data and 2 people have the same identity, same ID number, it would raise an error because that's not allowed. So you're only allowed 1 primary key per table. However, primary key can be across multiple columns. For example, let's say you had another table for employees, and you would have an ID as 1 column and a last name as a column. So in this case, every employee would need not only an individual ID, a unique ID, and a unique last name, which is not a good setup because it's possible to have people with multiple last names or same last name as other people. So that's just an example. It probably wouldn't work as well as you'd want it to, but it just shows how a primary key can be across multiple columns. Then we get to, so connecting the backend. This is something SQL is used to connect the databases, and databases are usually stored somewhere in backend. It's not really accessible from the front. So there's 2 ways of doing this. For example, if you were to, let's say you're working at some company and they had a server that holds the databases. So to connect to that, you would most likely need the host name of the server, or let's say if it's local on your own machine that you're running a server, you would just write localhost, and then you would require both the username, the password, and the database. So for an example, we'll just be using Python since it's super easy. Is this an okay size? Can you guys see this if I were to write something? If I were to just is this visible size, or would anyone want me to make this larger or smaller? Okay.
That's good.
That's good? Yeah, okay. All right. So if you were to connect to Python or connect to a database using Python, using a server, most likely you would have some sort of function, and then you would have the name, my database, doesn't really matter. You would have you'd use whatever library you're using. So most likely one of the more popular libraries, I think, is MySQL, and it's probably some .connect or something. You don't need if anyone's doing this along. You don't need to do this part because it's just an example of something you did. We're not going to go down this, like we're not going to use MySQL, so we're not going to be importing anything. But most likely it looks something like this, where you'd have your host, and you'd have some name like localhost. You'd have some username, probably called something like root. You'd have some sort of password and something just easy pass. And then the database name usually is what it looked like. Something like a mailing list, if you wanted, for example. However, we're not using MySQL, so we can just comment this out for now. We're not actually going to use this, but that's just an example of what it looked like. You would that usually have some method where you connect to it and you just provide all the information, a parameter, and it connects for you. What we are going to use instead is SQLite, or yeah, I think that's how it's pronounced. It's essentially a serverless and self-contained SQL library and database engine. It's included in the Python standard library, so there's nothing you need to install. And I guess it's just useful because the database is locally contained. So if we try to use this instead, and we did, let's actually do one we'd use, create database, and we'd usually have some file parameters. Let's just move down for now, and we'll have a main down here. So let's name the file of the database. So we're to do something such as, so do a raw string. For anyone that doesn't know what a raw string is, essentially any sort of like slashes like you normally do, you'd see like a backslash or something. Usually in a string it'd be interpreted as something else, like this would be interpreted as a new line. However, if you're trying to do something like a directory where you're going to like this into like some, or actually other way, but you had some directory into this, into some file here, something like that, then as a raw string, it would essentially ignore any sort of slashes. It just treats it as like a string and no sort of special characters. So let's just name our, whatever we want to call our database. We can just call it, I already have a test database. So what can we call this actually? I'll just call it SDHacks. We have a database called SDHacks. And okay, so now let's call it create database, and we'll bring that in as the name. So, okay, so now we go to here, and then now our database name is passed over. So what we're gonna do is we're gonna create a connection to a database. We'll just start it off as none, for example, and then we're gonna put a try block. And then in it, we'll try to connect. Oh, actually, yeah, I've got the port, sorry. So we're using, which one we're using? SQLite, so that is for SQLite 3, I believe. And then also while we're there, let's import error, just for good use. Okay. So we're going to connect. We're going to use this library, SQLite 3. Connect. And which database we're going to connect to? We're going to connect to our file name, our database file. And then, if it's successful, let's just print out the version so we know it works. And then let's have an exception catcher. Error as E. So this is just if something goes wrong. And then finally, we'll have a finally block. So since we just try this, if no errors, then we finally do something. If connection, basically, if our connection was successful, it should equal, our connection should no longer be none. So as long as this is not none, just close, which means just close any connection we've made. So if we were to run this, oh, sorry, wrong file. Oh, so we didn't call the main. Okay, and we just got if. It's just standard like procedure that most people do when they write a Python document. It's just if this is the main file we're running, call the main. Okay, let's run this again. Oh, I should probably check if there's any questions. Sorry. Oh, okay. So now we notice in our our directory, now we have a database called SDHacks. So if it can connect to this database that we find, it will just connect to it. And if it can't find it, it'll create one that can connect to it. So there's no risk. If I were to run it a bunch of times, it's not going to create a new one every time. If there's one that it can connect to, it'll connect to it. If not, it will make a new one. There's no like risk of overriding it or like completely making a new database that covers over it. So, okay, and from that point on, now we want to make a table for this database. So let's write another function, class one, create table. And again, we're just going to bring in the file. And this time, let's also bring in, we can, actually, it doesn't really matter. We can just name it how it is. Actually, no, we need that. Sorry. So we'll have a table name that we'll bring in. So back down here, let's have table name equal to, don't remember what I called this. We'll just call it employees. We'll do a table for like employees that you want to add. That's fine. Okay. So now we'll call this function create table file and then our table name. So there's a bit of setup to this, but once you create your database and you create your table, after that, it's quite easy to send it to send SQL like queries to receive and add any data, sort of data that you want. So go back to our create table. Just check what I wrote. Okay, so we'll have a connection once again, because now we know this table works. We don't need to try it. We just know there's a connection that works. Okay, and then we'll have a connection.cursor. So where your cursor is essentially, think of it as like the object of, if that makes sense. It's like the object that you want to call all methods on, which you'll see in a bit. For example, c.execute. So this is where we like execute any sort of commands we want to do that we want to send to send all our queries to the table. So in this case, let's make a triple string so we can do multi-line. And we'll have here, we'll start by creating a table, create a table, and we'll do if not exists. And what that essentially is like it says, if a table doesn't exist, create a table of that name. And what do we call this table? We'll call it employee table. And then its parameters, which would be, let's have an employee ID. And then we'll make this of type integer. And we'll write primary key not null, because we want a primary key. It's usually pretty important to have a primary key in your table to make sure you can keep track of what's in your table, make sure you have no duplicates of any sort. So have a primary key. And then let's have also last name. And then, so var, this is just a like variable character, and you give it a length. You can have it max 255 characters. And we'll have a first name, same thing, same concept. And let's just do, I was gonna do an address, but probably extra work is not needed. We'll just do a salary to make it short. And then one more thing, a salary. So from this point on, these are your parameters for your table. And then if anyone's ever, worked with Git, when you do any sort of work, you want to commit, right? So in the same thing with a connection, we want to commit any sort of work we've done. And then after that, let's just close our connection. So if we run this, nothing looks like it happens, but essentially inside our database, we've now created a table. And like the creation of a database, there's no risk of erasing it of any sort or rewriting it. So you can run this like as many times as you want. There's no risk. But just to get out of the way, we'll just comment it out for now. So we should have a table now, essentially. We should have a table now, and now all we have left is, to have our methods for this table. And so altering tables, it's pretty there's pretty only 3 set things to do. Insert command, it just, adds new entries to a table. Delete, removes entries from a table. Update and set are used to, you pick which entry to update, and within the entry you can set new values for any sort of column. All right, so let's just do a basic. Well, first let's have a read, so we can actually read what's in our table. So we define a, let's call it read employees. And all we need to bring in is the, we can make this simpler on ourselves. We can either, every single time, if you notice in the create table, every single time what we did was we brought in the file name, we started a new connection, and then we closed the connection. So that's one way to do it, or to just, save time writing. What we can also do is we can just have our connection down here, right? Connection equals SQLite 3, and then dot connect. Or connect our file. And instead now, in everything, all we can do is just pass in the connection rather than pass in the file every time. And then this way we can have down here connection. We close the connection after. So let's do a really basic reading thing. We can reestablish our cursor because that's always useful to have. Cursor. And then we'll have an execute command. We'll do one of the first things we learned, the select. We can select information we want. So let's just select all values, all entries from this table. Select from, I believe we called it employees. And then after that, now we can set this to something. So we can have something called employee list equals, and so after we execute it, it gets stored in employee list. So from this point on, all we got to do is for row in employee list, we just print each row. And we can try this, although I'm pretty sure there's nothing in our table. We can try it. Read employees, connection, and oops, let's see. No such table. What did we actually name it? Employees. Sorry, hold on. No such table employees. Where did we connect this to? Employees. Oh, employee table. Sorry, we named the table. Employee table. Okay. So yeah, there's nothing to print because we have nothing in our table. So why don't we add something? We can have we just have add employee. This is probably the longest command we'll have. Same concept. We'll have a cursor that we always pass in the connector, and then let's execute another command that we want to send. And this time we'll use the insert. So we'll insert into our table employee table and the values we want to insert. So in this case, we'll insert, what do we have in our table? We'll insert employee ID. So we'll have, actually, we'll make this simpler. It'd get kind of long to write everything inside the actual string itself. So we can use essentially string formatters, which are, it's part of Python, not part of SQL, where we have, let's say we have 4 things we want to insert. Afterwards, we just write dot format, and essentially everything we put here, it would fill in. Like the first name would go into 0, second into 1, 2, 3, 4. So what's the things we want to pass into this, by the way? We want to bring in our employee ID. We'd want to bring in the last name. We want to bring in the first name of anyone. And I think our last thing is our salary. So we have 4 things we want to bring into this. And now we can just copy this, put it right here. So essentially every command we do, we'd insert into this table a new entry with the values, in this case, employee ID, last name, first name, salary. And so since these are actually, these 1 and 2, these are actually strings, what we'd have to do is we have to add strings around them. And we can keep the others as just integer values. So the 0 would correspond to employee IDs, 1 would correspond to last name, 2 would correspond to first name, 3 would correspond to salary, and then string format in Python will do that for you. Does this make sense to everyone so far? Everything good? And then, okay. Just feel free to comment in the chat if you have a question. And then like everything else we have to commit, and then this should be good enough. So let's try using this new function we wrote. We're to write add employee. Let's name this one. I guess I'll be the employee for this one. So we gotta bring in our connection. We gotta bring in employee ID. Let's just write 1, 2, 3, 4, 5 as an ID. We can put my last name, my first name, and my salary. I don't know, like $2. So we're to run this now. Put 1, 2, 3. How many do I have? 1, 2, 3, 4. 2, 3, 4. So I'm tired right now. This is so I might make a lot of mistakes while I write this, but I enter into these values. Oh, I forgot to close off this parentheses. Sorry, and these hold the 4 parameters we want to add. So if we try running this again, this not works. Okay, so now when we read the employees, we'll notice now there's one employee. This is me. So to check if our primary key actually works, we can add another employee, and that's his last name, that's his first name, salary doesn't matter. And but this time what we have is we have the same unique ID number, and this shouldn't be allowed. So if we run this, this should raise an error that there's unique constraint failed. So essentially that we can't have 2 entries with the same primary key because that would break it. That's just not allowed because it's the point in primary keys. So this doesn't work, but let's just add another employee. Random number, random last name, call Bob, and big salary. Okay, so now we run this. Oh, sorry, I forgot to save. Now we run this. It's still, where's my primary key? Employee ID. Oh, sorry. So the issue, what you're seeing now is something I forgot to mention. Essentially, within this, so the point of a database is that it saves outside of your program, right? So every time you run this, you don't have to like start a new connection, or sorry, you don't have to start a new database. So right now in the database has an employee that known as this guy, and it has this number. So if I were to try adding this guy again, it's going to say, oh, he already exists within this table. So I'd have to comment this out for now. I'm going to run this. And now if we look at it, we're only adding 1 employee. But if you notice, the other employee is still saved within the database. So I guess that's like the main reason using databases outside of just storing everything in a list in your actual program is that if your program goes down, you're not going to lose your list of people. And he stays inside. So now this other employee is also in, and let's just comment that out so it doesn't raise another error that I'm trying to add him a second time when he already exists. Let's just create something simple like a remove employee. Let's say we want to get rid of someone. Removing is much easier. We only need our connection, I believe. Actually, no, we need a connection, and we can remove based off of employee ID. So, and in this function, once again, we'll have our cursor, and then c.execute. We're going to execute a new command. And this time we're going to try to use the delete command. So delete from employee table, and then we'll use the where. This is our condition, where employee ID equals, and then dot format. In this case, I guess it's just employee ID. And we'll go like that. Okay. So now we try running remove employee, same connection, and let's remove the first guy. 1, 2, 3, 4, 5. We run it. Well, notice now in our database, all we have left is the second employee. And a good thing about the delete function is that you would think in other languages when you try to remove something that doesn't exist, it usually raises some sort of error. If you try deleting an entry that doesn't exist, nothing happens. So if I were to run this multiple times, it's not going to raise an error that it's not deleting anyone. It just won't do anything. So it's pretty safe to use. And finally, let's just have one more function. And we'll have something called adjust salary. And then we'll have, once again, connection, the employee ID, and we'll have the new salary that we want to bring in. New salary, sorry. Okay. And once again, we'll have a cursor, and then execute. And this time, what we're going to use is we're going to use the update command. So we'll have update from employee table. Okay. Employee table, and then we're going to set the parameter is called salary. So we're going to set the salary equal to whatever number we're given, and then we'll have a condition. We don't want to update everyone's salary, right? We're going to update where employee just in where employee ID equals this other condition. So once again, we'll be using string format. It's just a safer way of writing into strings, so as to avoid a super long string that is kind of like impossible to read. So we do this again. Oops, sorry, format. So our first one would be the new salary we want to set. So that would be salary. And the second is the employee ID that we want to update. Anything else? Let's see, where employee ID equals that, and then we may have to set these as a string. I'm not too sure, but we can see if this works. And then once again, we set the commit, and then it should be good. So let's try running this now. We'll have, actually, we can re-add this guy since he's no longer in the table. I'll do adjust salary. And then let's adjust the salary of the first employee, 1, 2, 3, 4, 5, and his new salary, which it was currently 2. We'll change it to 100. So let's actually see if this runs. It might raise an error. Yeah, okay. Unique constraint failed. So again, so let's do this. Let's comment out actually. So we want to re-add him first. So let's see what's in our table once we add that guy. Unique constraint failed. Okay, who's in here? Okay, so we have these 2 employees, and we want to adjust the salary of employee number 1, 2, 3, 4, 5. So he's not defined. Okay, so there was an error here. New salary, that's the issue. So now when we run this, employee ID, employee, okay, there we go. Now we run this, syntax error, here from, update from, oh, sorry, there's no from, it's just update this table, update the table, set the salary equal to the new salary, where the employee ID equals the employee ID. And we try running this. Okay, so now we check. Oh, I didn't. Did I change it? Adjust salary. Okay. We want to change the salary. Let's change it to something like 1,000. Or let's check who's in here. We have these 2 employees. Okay. We're gonna update employee. Oh, sorry, I wrote the wrong ID. That's why. So since it couldn't find an employee with the ID, nothing was adjusted. But we want to adjust employee 1, 2, 3, 4, 5. We run it now. We just see the ID has changed to 1,000. So these are like these commands are here, the most basic SQL like queries you can do. You know, you can insert information, you can delete information, you can update information, and these are pretty much the ways to communicate with your database or your server. I believe that's about it for the most basic of commands. Honestly, just remember to close your database afterwards. I don't think there's any more slides. Yeah, okay. Does anyone have any questions about anything, or would like me to repeat and go back about anything? This may have been, it might have been kind of rushed. I'm very tired right now. But let me read the chat if there's anything. Okay, well, if you guys don't have any questions, that's pretty much the most basics of SQL and how to connect to any sort of database and how to send SQL commands via like another language. So that's it. Okay, yeah. Yeah, it doesn't seem like there's any questions. Okay, yeah. Thank you guys for attending. It should be all there is. And good luck on your guys' hackathon, you know. Hope to see something cool.